4.2 and 4.5. Operations with functions, including composite functions and inverse functions. You don't need to take notes today. You already have notes on this. We're just going to revisit the topics. Let's start with story time. Once upon a time, there were two functions, f of x and g of x. And f of x was x squared plus 3x, and g of x was 6 plus 2x. Well, they got along really well, and they decided, you know what? We should be roommates. So f of x said to g of x, hey, do you want to go ahead and move your stuff in? And g of x, she said to f of x, good idea. Let's just add all our stuff together. That would be like adding functions. So in order to add them together, you just put a plus sign here. Well, we need to combine like terms. F and g of x were talking about it, and they said, you know, anything that we have the same, we should just put it on the same shelf. And so they looked to see what they had that was the same. They both had x's. One had a 3x and the other had a 2x. And g of x, she said to f of x, hey, let's just add our x's. We'd have 5 of them all together. And so they added up their x's, and they had 5x, so altogether they had x squared plus 5x plus 6. Well, one day they got in a really big fight, and g of x got really mad and decided to storm out and take all her stuff with her. So that would be like subtraction. And g of x, she wasn't going to leave anything behind. She was going to subtract everything she had, including the 2x. Once again, we're combining like terms. Notice the like terms are underlined. So we end up with x squared plus x minus 6, and g of x slammed the door behind her. Well, g of x had some time to think about it and realized that their friendship was far too valuable to throw out for one argument. So she decided that she would make a gift for f of x. She picked a -2 out of her kitchen cabinet. They were some special spices and seasonings. And she thought, you know what, I'm going to mix something together for f of x and bring it over there as a present. So she mixed up her -2 into her function and got 6 minus 4, which was 2. So she took that 2 and said, here, F, I'm going to give you my 2. Well, F was so excited and said, you know, I love 2s. In fact, I'm going to take that and I'm going to mix it with some other things, and I'm going to make us a really good dinner out of that. So F plugged the 2 into her function and got 10. And that was the happy ending to the gifts that they worked with, starting with a -2, producing a 2, taking the 2 and making a 10. And it was a delicious function value. Well, a few days later, F thought, you know, G is so nice to me. Maybe I should kind of do the same thing for her. Except I'm going to start with something different in my kitchen. I'm going to start with a 1. So F went into her kitchen and she started mixing together a 1 with her function. And when she was done mixing up the 1, she got 1 squared plus 3 times 1, which was 4. And she thought, wow, I bet G is going to love that 4. So F gave her 4 to G. And G thought, you know what? That is so awesome. I love this. And she said, hey, F of x, I'm going to take that 4 and I'm even going to make something out of that because I love 4s. So G went into her kitchen and she took the 4 and she put it into her function and she got 6 plus 2 times 4, which is 6 plus 8, which is 14. Oh, that 14 was delicious, and so they had that for dinner. And that was the result of all the cooking and sharing. So F had started with a 1 made a 4, and then gave the 4 to her friend G, and G did some cooking with that, and she got 14, and that was the delicious dinner they had together. Well, with all this cooking, one day G said, "You know, F, can I just have like all your recipes because everything you make is so good, and then I could plug it into my function anytime I want and just make anything like you make." And F said, "Sure, no problem." So G said, "Hey, I'm going to take everything you have and put it into my function so I can make yummy stuff anytime I want." And so that's why G wrote 6 plus 2 times everything yummy that F has. So she took the whole F function, that was x squared plus 3x, the whole thing, and put it in her function where she had her x. Well, she couldn't leave things all cluttered like that, so she decided she would go ahead and multiply things out so that her combined function, this composite function, would be just what she wanted and be all nice and efficient. She could leave it like that, or if she wanted to, and she was more comfortable with it like this on her counter, she could leave it like that on her kitchen counter. But it'd be the same recipe either way. Well, F and G lived happily ever after as super happy, fun, friendly roommates, and they did lots of exciting function cooking together. Since F and G are functions, you might find it not surprising that they numbered the rooms in their house. Yeah, that's how functions are. Well, one day, F and G were talking, and they said, well, first of all, they said a function is a y value. They said that all the time. But they also said, you know what, let's go to our number 4 room. It's getting a little bit cluttered in there, and let's just do a little subtraction. This can be read F minus G of 4, but it can also be helpful to read it F minus G at 4 to remember that this is an x value location. So they went over to their room number 4, and it won't surprise you that they kept track of how much stuff they have in there because they're functions after all. And so F said, okay, I'll tell you how much stuff I have in room 4. I have 1 item. I have 1 item. And from that, we're going to take away how much stuff you have in room 4, and it looks like you have 2 items. 1 minus 2 items. Well, that's a negative item. Do you think that bothered them? No, they were functions, and they thought -1 was great, even though it's kind of weird for an amount of things in a room. They decided that they'd also go to room 2. And just for fun, they'd add up all the stuff that they have in that room. Which room? Well, they went to room number 2. In room number 2, F said, let me see how much stuff I have. Oh, I have 3 things in room number 2. And G said, in room number 2, I just have 1 thing. Well, that was easy to add up. Altogether, they just had 4 things. Well, they were having so much fun adding and subtracting things in their rooms that they decided to do a little treasure hunt. So G said, okay, I'm going to go first, and I'm going to go to room 1 and see how much stuff I have. So G took a look at room 1, and G had 3 things. And G said, okay, now here's what I think you should do, F. I think you should take the amount of things I have and make that the room that you go to and see how much you have there. F said, okay, that sounds fun. I think I'll go to room 3 because that's how many things you had in room 1. So F was going to go look in room 3. So F went to room 3 and said, oh my goodness, I don't have anything there. I have 0. And so that was the end of that treasure hunt. They decided to try it again just for fun, but F said, I want to start this time. I want to start this time. I'm going to go to room 4 and see how much stuff I have there. So F went to room 4, and it looked like she just had one thing there. And she said, okay, here's what I want you to do, G. I had one thing in my room. I want you to take that number 1, and I want you to go to look in room number 1. G said, okay, I can go look in room number 1. So G went to room number 1, and G said, you are never going to believe this. I don't have anything in that room. And they said, well, maybe it always works out that way. Maybe we'll always get 0 things. Okay, so then G said, let's try it. How about F, you go look in room 2 and see how much stuff you have. And let's see if we always get 0 for the answer. So F said, okay, room 2, I have 3 things. So G, you go look in room 3 and see how much stuff you have. G said, okay. So G went over to 3 and looked it up, and oh, there wasn't 0. That was a coincidence on the last 2 things. Turns out that there's 3 things. And that was the final answer for that composite function. Let's finish up with inverse functions. We'll talk about the wardrobe of f of x. Anytime f of x, let's get this focused for you. Anytime f of x wore 3 for her shirt, she always wore 5 for her pants. That notation, f of 3 equals 5, is the same as the ordered pair 3, 5. In similar fashion, no pun intended, if she wore a 4 for her shirt, she always wore an 8 for her pants. So when we see f inverse of 5, it just means if she wore a 5 for her pants, what shirt went with it? If you said 3, you were right. Now what about these composite functions that also involve inverses? We just need to start on the inside. F of 4. If she wears a 4 for her shirt, what pants go with that? Well, the 8s. They're really pretty pants. And so we'd rewrite this as f inverse of 8. And now we have to answer a new question. If she wore 8 for her pants, what does she wear for her shirt? It's a 4. See how it kind of just bounced back to what you started with? Let's try this one. F inverse of 8. Okay, so if she wore 8 for the pants, what did she wear for the shirt? A 4. So we replace everything in the parentheses with a 4. This got replaced with a 4. Can we answer this question? F of 4. Let's just go up here. If she wore a 4 for her shirt, what pants did she wear? The 8 pants. And that's it. And yep, the answer bounced right back. So inverse ordered pairs are just the reverse. You switch the x and the y. So this ordered pair would be like 5, 3 instead of 3, 5. It's just reversed. In fact, every time you graph inverse functions, the reflections over the line y equals x, which includes ordered pairs like 1, 1, 2, 2, 3, 3, 4, 4, negative 1, negative 1. Here's an example of 2 inverse functions. Y equals x squared, starting at x equals 0, and y equals the square root of x. We've covered these recently. Notice that the ordered pairs are reversed. So if you're asked to take a function and find f inverse of that function, you're just going to switch x and y and solve for y. If the y hasn't been written for you, you write it in place of f of x. Now, I switch the x and the y. That's in the green marker. Notice the x and the y are in different places now. In order to solve for y, I first need to add the 8 to the other side and then divide by 5. Don't start with the 5, you have to move the 8 first. See, I added the 8. Now I'm going to divide both sides by 5. You can see I've divided both sides by 5, so I have y equals x plus 8 over 5. And that equals f inverse of x. The end.